Assalamualaikum warahmatullahi wabarakatuh. My name is Tengku Nazrin Syaputra bin Tengku Muhammad Faisal. My student ID is 2023834766.
And my name Haris Fadilah bin Sariful Bahari, and my student ID is 2023696688.
Okay, last but not least, my name is Arif Hakimi bin Hamzan. My student ID is 2023499614. We from class AS1241B. Okay guys, let we start now. What is related rates? A related rates problem is to compute the rates of change one quantity in terms of the rates of change another quantity whose rates of change is known. The rates of change is usually with respect to time. Why use related rates? We use related rates because related rates in calculus is to understand and analyze how the rates of change of different variables are interconnected. We also use related rates for two situations. The first one is solve real world problem. Second one is enhance problem solving skill. How to solve? Step by step. The first one is we need to identify the given information and the unknown. They assign variable to all quantity that vary with time and any other that seem relevant to the problem. Define each variable and draw a diagram if possible. The second one is we need to identify the rate of change that are known and to be found. Interpret each rate as derivative. The second one is we need to find the equation that relates the variable whose rates of change were identified in step 2. Okay, next. The next step is differentiate the equation both sides with respect to time to product the relationship between the known and unknown rates of change. And then lastly, we need to substitute. You know substitute? Substitute it, I don't know, value for the rates of change and the variable and solve for the unknown rates of change. Okay, what we want to do now? We want to discuss about the question that is in the Calculus 1 textbook entitled about the application of the differentiation related rates. This question can be found in the Calculus 1 textbook. You can locate this question in tutorial 28 page 122 question number 5.
Let's to the next topic. It's about problem statement. They are given the question. The area of a triangle is given by A equal to 1 over 2x squared. If the area is decreasing at the rate of 4 cm square per minute, find the rate at which it is changing at the instant when the area is 200 cm. First, we need to identify the given information and the unknown. Then assign variable to all quantity that vary with time and any other that seem relevant to the problem. Define each variable and draw a diagram if possible. AT equal to area of triangle equal to 1 over 2x squared, and area we describe as a equal to 200. And now we need to find dx over dt. Second, we should to identify the rate of change that are known and to be found. Interpret each rate as a derivative, which is dA per dt equal to -4. We get it from the answer. We get it from the question, which it mentioned decreasing at the rate of 4 centimeters square per minute. That's why we use -4, because it decreasing.
So, the third one is find the equation that relates the variables whose rates of change were identified in step 2. It is AT equal to a half x squared. Then, differentiate the equations both sides with respect to the time t to produce the relationship between the known and unknown rates of change. The example is dx per dA is equal to 1 per x. Dx per dt is equal dA per dt times dA per dA. Now we need to find the value of unknown at the equation. First, 1 per 2 x squared is equal to 200. And after that, x squared is equal to 400. And x is equal to square root 400. And after that, it will become x is equal to 20. The next step is substitute all known values for the rates of change and the variable and solve for the unknown rate of change. So, we know that dA per dx is equal to -4 and dx per dA is equal to 1 over x, and also x is equal to 20. So if we look at the equation, dx per dt is equal to dA per dt multiplied by dx per dA. We just substitute dA per dt is equal for -4 and multiply by dA per dx, and dA per dA is equal to 1 over x. And after that, we just substitute another x to the 1 over x, and it will be -4 multiplied by 1 over 20. And we got the answer -1 per 5. And the x per dt is equal to -1 per 5 cm squared. Or we can use
Conclusion. Relate rates are often used in real-life scenario to analyze how different quantities are changing with respect to time when they are related to each other. The primary function of relate rate is to model and understand the rate at which one quantity change constant, the rate of change of another related quantity. This concept is particularly useful in fields such as physics, engineering, biology, and economy. This is our references.